Who memorize, who remember what is the vertical line test is?
What like that, and it's where the points, it's not like,
What is it about? Yeah, you got it, but what is it for? If it's not passing, what is it for? Yeah, is the function or not? So vertical line test is to test if a graph is a function. Okay, so last time we learned about vertical line test. Is this one a function?
Yes.
Yes or no? Who said no?
Yeah.
If you cut it, no matter where you cut it, you only cut it once, right? So it is, yes, it is a function because it passed the vertical line test. It is one pass the vertical line test? No, because if you cut vertical line, it's cut like 1, 2, 3, 4, 5 points. So this is not, it's not function. It is not a function. Okay. So what did you guess? Today we're gonna use what? You have vertical line test. So what do you guess? Horizontal line test. We're gonna learn today horizontal line test. Should be easy. The same concept. If you cut the you cut the horizontal line. If you cut the horizontal line and if they miss the graph more than once, that means it failed. Okay, it can only meet only once. Like this one, you're gonna pass the horizontal line test. This one gonna fail, right? Because this one, when you cut the horizontal line, it's like multiple points, more than once. This one, if you cut the horizontal line test, no matter when you cut, you only miss once, right? Only 1 point. So this pass. So now you're gonna ask yourself, what is horizontal line test for? If it's passed, and what happened? Okay, here, vertical line test, or a horizontal line test. Okay, horizontal line test is today. Give me one paper. Oh. Oh. Are you all coming back? No. Oh, okay. To test if the graph has an inverse. So that's what horizontal line test for. Actually, if the function, so you write this one first, and then you're gonna write this. If the graph passes horizontal line test, HLT, okay? We say the function is 1, 2, 1, 1, 2, 1. 1, 2, 1. 1, 2, 1 mean 1x only give 1 y. For every y, you only have 1x. We're gonna learn more about that on calculus, not this class. So this class, we're gonna focus on the inverse. So if the function they pass the horizontal test, then it has the inverse. Okay. Nothing special, just inverse. Because you heard the word calculus and then you gotta figure out. Oh, this is graph. This is like random graph. And then cut it. No. You already set yourself, you set your mind, oh, I'm not gonna understand it. And then you didn't understand it. It's that easy. Nothing special yet. Are we good? Yeah? So last time we're gonna find the inverse function algebraically. That means you need to do adding, subtracting, multiplying, that stuff. Today we're gonna find the inverse graphically. Graphically is much easier because you can just look at the graph, you can tell right away. Okay. Can I erase this? Did you write it down? If the graph passes HLT is horizontal line test, we say the function 1 to 1. The function is 1 to 1. Okay. And now we look at the graph. I'm going to show you how to find the inverse graphically. Okay. Let's stop this. Okay. So first on the homework, I'm gonna ask you to determine is the function is inverse. Look at the first one. Does it have an inverse? Yes or no? Does it pass the horizontal line test? No, right? If you cut right here, it's okay. You cut only 1 point. But if you cut right here, how many points? 3 points. So this is failed. So there's no inverse, then there's nothing you can do. So no inverse. That's the easiest one you can do. No inverse. Second one, does it pass the horizontal line test? Yes. If it passes, then you need to find the inverse. You wanna draw the inverse. Very easy. Look at this. First step, draw the line y equal to x. Y equal to x is the diagonal line like this. Because y equal to x, that means when x is 1, y also 1. So this one, 1, 1, right? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, because they all equal. X equal to y. Same thing here. Yeah, so that's y equal to x is the line, is diagonal line like this. The diagonal line like this. This is the y equal to x. Because when x equal to 1, y equal to 1. So 0.11, 2, 2, 3, 3, 4, 4. And that is the diagonal line. Okay, that's the first step. So the original graph, they're going to reflect over here. Reflect this axis, not the y-axis, not the x-axis, but this one. So this original graph, they're going to reflect over here. Okay, how can we draw this? Very easy. You're going to choose the nice point on the original one. What I mean nice point is you want to choose the point that right on the spot. Like the point that, like here, like this one, right on the spot, right? You don't choose the one like 0.5, 1.7. Don't do that, okay? Choose the easy point, the nice point. That means the point right on the spot. You can tell, like this point. What is this point? 3, 4, right? Maybe one more. How about this? What is this point? 0, 1, right? Let's choose one more. How about this? This is nice point, right? Right on the spot. What is this? -3, -4. Okay, I think maybe one more here. Okay, this one. -6 and -6. Okay, and then this one is 19. This is 4 and 5. Here, what you wanna do? Switch x and y to y and x. 4 and 5. Can you switch it? 5, 4. 3, 4. 4, 3. 0, 1. -3, -4. -6. Oh, this one -6 and -6. You're gonna plot this point and connect them. That's it. Then that is the inverse. Yeah. Easy, right? So 5, 4. Where's 5, 4? 5, 4 right here. 4, 3. 4, 3 right here. 1, 0. 1, 0 right here. -4, -5. -4. -5 right here. -6, -6 is the same one. Now connect them, okay?
Does it matter how many points we get?
The more the better. Yeah. Yeah, see now did you see this one reflect over this one? Yeah. So that is the reflection, that's the inverse. And basically that's we done for the homework. For the homework they're gonna ask you one more thing. Find f of 3. F inverse of -3. For example, the homework asks you f of 2. For example, if I want to find f inverse of -3, how can I do it? Do I look at the original graph or look at the inverse graph? The inverse one, because this is -1. Okay? Now look at the inverse, -3. Where's -3? Right here. Do I go down or go up to find the point? Go down. Do I need the black one or need the green one? The green one, because I look at the inverse one, the new one, I just do, right? Let's say this is 2, negative 2. Yeah, so this is equal to negative 2. Easy, easy. Last part. I recorded it, so if you didn't catch that, you can review it. Last part. Okay. So this one, you know how to. I will show you the way that you don't even need to draw the inverse, but you can tell what is this. Okay. Here we go. Have your attention. I asked you want to find inverse of f inverse of 2. Okay. Last time we need to like draw the inverse and you want to find what the point. But here, I don't need to draw it. I'm gonna show you how. This is f is x and y, right? F inverse is y and x because we switches, right? So now if I'm asking you about the inverse, instead of finding x equal to 2, I'm gonna find where is y equal to 2. Yeah, does it make sense? Usually we find x, right? You're gonna find where is the x on the x-axis. But because it's the inverse, I'm gonna find a y equal to 2. So y equal to 2, where is it? Right here, y equal to 2. So what is the x for here? 0. So the answer here is 0. You go backward. Yeah, because it's opposite. You go backward, right? So the answer here is 0. Yeah, that's it.
Wait, why do you
You have recording though. So y equal to 2 and then x equal to 0. And how about what we're going to do with this? The same thing we do on the lesson 18. This is just equal to f inverse of 2 plus t2. Okay? What is f inverse of 2? Oh, we just found it, 0. What is t2? It's negative 2, right? Okay, for the one without the inverse, you need to look at the x, like normally. But for the one with the inverse, you need to look at the y. For example, do one more thing, this one. Negative 5. Do I look at the y or look at the x? The y, right? Negative 5 is right here. Now I go here to meet the graph. What is the x? 4. So this is 4. Yeah? So you don't even need to draw the inverse because you just switch the x and y. Yeah, that would be it.